Welcome back, ladies and gentlemen. All right, are you ready for more? More conics? What could be better? Okay, so we are now going to be talking about the second situation in which you have a conic that originally is not in standard form. All right, so just a little reminder, general form is when you've got just like a list of terms. So like this guy right here at present is in general form, okay? And we want to turn it into standard form. That's the kind we use to graph. Okay, so that's like the graphing transformational form. Basically, it's the like nicer one. It's the one that's easier to use. It's the one we want it to be in, but it's not. So how are we going to fix that? You are going to use algebra. Duh, you've learned so much algebra. How do you not have an algebra skill to handle this, right? That skill that you are going to use is, wait for it, drum roll please, completing the square. And get this, as an added bonus, there are going to be some times where you're going to have two quantities squared. So you get to complete the square twice. Oh my God. Doesn't that just sound so great? I know you're like, oh, this could not get any better. All right. So I can't wait. Let's get started. Okay. First order of business, before you try to complete the square or do anything, you should take a look at the equation and ask yourself, what kind of conic, I don't really want to use that color, what kind of conic am I dealing with? Okay, so you should look for how many terms are squared, are terms positive, negative, leading coefficients, all that stuff. So I'm noticing that there's only one term squared. Anytime that happens, that means we have a parabola. Okay, so partially because I want to like limit my y squared being negative if I can, I'm going to add the y squared and I'm going to add the 2y to the other side, because whenever you are completing the square for this unit, you want to kind of keep everything that's part of the same variable together. And in a parabola, you want to put all that stuff on one side. So that's going to leave me with the 4x and the negative 33 on the left side. And I'm going to have y squared plus 2y on the right. Now, hopefully you remember that when we complete the square, that means we have to add a number so that we have a perfect sum quantity squared on the right-hand side. That number is always going to be the b value divided by 2 and then squared. So in this case, that would be 2 divided by 2 squared, which is 1. Now, I can't just like randomly add 1 to one side and totally ignore the other. That'd be ridiculous. So I have to add 1 on the left-hand side also to keep my equation in balance. Okay, so that means I'm going to have 4x minus 32 equals y plus 1 squared, because that's what this guy factors to. Now my square is complete. I have a perfect square. Now, I do want to remind you that if the y is squared, I've got something like, and I'm just going to write it with the 4p first. 4p and then in parentheses x minus h equals y minus k squared. Right now, I do not have this leading coefficient factored out so that it follows this same format. So what I'm going to do is factor out the 4, and then I will have x minus 8 equals y plus 1 squared. Okay? Now, I do want to point out, even if that 4 hadn't divided out evenly, we would still need to take it out, because the leading coefficient in the standard form has to be 1 for both of the x and for both the x and the y. So it would have to be 1 right here inside the parentheses. All right, now this video that I'm going to make today is just going to focus on the completing the square part. You can go back and graph these after we've done the completing the square portion of this, all right? Or we might get to it in class. Kind of all depends on, where life takes us. But this video is just going to focus on the algebra part. So we're going to skip this graph bit for now. You should do it later at some point, whether it's in another video or in class. And we're going to skip number 2, and we're going to go to number 3, okay? And the reason why we're going to do that is because now we're looking at a different shape. So at this point, I'm looking at it, and we have 2 quantities squared. So here's what I can tell you. Not a parabola. So parabola out. And then because we have this positive sign, it is not a hyperbola. So the hyperbola also out. Is it an ellipse? Is it a circle? Not quite sure. I mean, I have my guesses, but we're going to need to complete the square in order to figure it out. So a little bit like the last one, we want to keep all the terms that are the same variable together, like clustered, but because in an ellipse or a circle, everything that relates to x and y is on the same side, I'm not going to move these terms, okay? Y squared minus 26y. But I am going to move this number because whether we have an ellipse or a circle, either way, they're going to be equal to a value. So I'm going to subtract negative 224. It's going to be on the right side. Now, I hope you've guessed it, that this is the moment where you get to complete the square twice. So exciting. Okay, so I'm going to pick a number here. That is going to be 16 divided by 2 squared. So that number is going to be 64. And then the number I'm going to put here related to y's is going to be negative 26 divided by 2. That number squared, so that's 13 squared, so that's 169. And remember, when you add on one side, you have to balance the equation out on the other side. So I'm going to add 64 and I'm going to add 169. All right, so that's going to leave me with x plus 8 squared plus y minus 13 squared. And that's going to be equal to, well, these two numbers together are 100 and, let's see, 220. That'd be 16 and 60. 220. So this is 233, right? So I think we're going to get 11 over there. All right, right? Yeah, so we're going to get 11. Don't freak out, by the way. If you're like, I can't take the square root. Oh, I'm so silly, guys. Sorry. I was just like doing the math in my head, and I was like, wait a minute. That's actually not 11. That's 9. And I went backwards. Anyway, if it was 11, it would have been fine, by the way. Okay, so turns out, because this number, there's no coefficients in front of our x or a y, that this is a circle, all right? And again, we're going to go back and graph these later, but hopefully you can tell, hey, that follows the x minus h plus y minus k squared equals r squared. So that guy's totally a circle. All right, moving on to number 4. Okay, again, we've got a plus sign and 2 variables squared, so I'm going to guess this is either an ellipse or a circle. Let's see which one it is. So same idea. In fact, if you want to pause the video right now and, try out the completing the square just like the last one, be my guest, okay? If not, you can totally just keep listening. All right, I kept it quiet in case you were trying to work, but I've run into a bit of an issue, guys. So I've got these numbers in front of the quadratic, like the x squared and the y squared. Can't have that. If you're going to complete the square, those need to go. So I'm going to have to factor 16 out, which is going to leave me with x squared minus 2x. But I still have a blank that I'm going to need to fill in. And then similarly, I'm going to factor out the 25. So I'm going to be left with y squared plus 2y plus, again, some sort of blank, I don't know yet, equals negative 16. All right, the blank part, not too bad. We're going to get 1 and 1, because 2 divided by 2 squared is just 1. But I didn't really add 1 when I added that in the x's. I really added 16. Okay, so we're at 0. And then I didn't really add 1 here with the y's either. I added 25. So at this point, I have 16 times x minus 1 squared, that quantity, plus 25 times y plus 1, that quantity squared, equals 25. All right, this does not look like the last problem, because in the last problem, I didn't have these coefficients hanging out here. So this is probably not a circle. In fact, it isn't a circle. So if it's an ellipse, I have to be equal to 1. And so to do that, I'm going to divide everything by 25. All right, so working backwards, that's going to equal 1 on the right-hand side. I'm going to have y plus 1, that quantity squared, over 1. You don't have to write the 1 if you don't want to, but you can. Totally fine. Plus, and then x minus 1 squared over. Now, here's where, if you're not careful, the mathematics will get you. So we are multiplying by the fraction 16 over 25. But I want to know what we're dividing by. So we have to essentially take the reciprocal. So we are dividing by 25/16. Okay, I'm going to say that kind of one more time, and I'm going to write that kind of like over here. We have 16 over 25 times x minus 1 squared. But I need it to be x minus 1 squared divided, because that's what that fraction symbol means, by a number. Right, this is division. So how do I flip it backwards? I have to take the reciprocal. It's like when you're dividing by a number, and so you multiply by the reciprocal, you're basically going backwards, okay? So that's why 25/16 is in the denominator, okay? And then last but not least, let's take a look at problem number 5. So notice we've got a negative here. My money is on that hyperbola, all right? So similar setup, 9x squared plus 54x, and then minus y squared plus 10y, and then equals negative 55. Okay, so the 9 gets factored out of the x squared and the 54x. So that's 6x plus something. And then the negative gets factored out. That's a GCF, okay? So that would make this y squared minus 10y plus a number. And then we're still equal to negative 55. Okay, so I'm going to get 9, because 6 divided by 2 is 3, which really means I'm adding 81. All right. And then I'm going to get 5 squared, which is 25. So I'm really subtracting 25. So all in all, I'm subtracting 80, right? So I'm going to have 9 times x plus 3 squared minus y minus 5 squared equals 1. Okay, so you might be thinking, I thought you said this was a hyperbola, Fry. I did, because it is. So we have that little situation again where we're going to have to take the 9 divided by 1, and we're going to have to rewrite that so that it's the value we are dividing by. So it's the quantity x plus 3 squared over a 9th minus y minus 5 squared equals 1. I know, this guy looks a little funky. It's all right. It's totally fine. Okay, I would say you should be able to handle the rest of these problems on your own. I've showed you kind of an example of one of each. You totally got this. Key things, just remember to keep track of all your terms. Remember to add whatever you added on one side to the other side, right? Balance. Okay, maybe make yourself a little note. Remember to make sure you're balancing your two equations. Okay, thanks so much for listening. Have a good one, guys. Bye.